Hi guys, today is 1.3a, measurement of rotation for finite math and trig, and we're going to jump right into drawing angles and a little bit of like standard vocabulary for trigonometry before we move further into this chapter. So the first thing we need to do is do a little bit of review, and first we need to remember that an angle is formed when two rays are joined at their endpoints. Right? Rays are like half lines, I guess you could say, right? There's a point and then it goes on forever in both directions. Angles start at the initial side. So let's say this is our initial and end at the terminal side. So right now, you might not know why I'm picking, the bottom one for initial and the top one for terminal, but it's not a big deal right now. However, rather than like wondering, right, which one is initial and which one is terminal, there is this thing called standard position. But before that, within the angle, a curved line is drawn, right? And that shows, it's going to show us a direction eventually. So in finite math, we're going to be adding an arrow of direction. Okay, so in standard position, mathematicians have decided that we're always going to start at the same place. And an angle is in standard position if on an xy axis, the vertex is at the origin, so right here in the middle, and its initial side is on the positive x-axis. Okay. So that means we're going to go this way. And we're always going to start there. Okay. So an angle in standard position is considered positive if we start on the initial side. Okay, so both of these we're going to do, regardless of if it's positive or negative, it's always going to start here on the positive x-axis. If the direction of the angle is counterclockwise, okay, now please remember that our clock goes 12, 1, 2, so this is clockwise, right, going to the right. Oops, sorry. There we go. So if it's counterclockwise, let's draw a 45-degree angle. So we know it's going to be exactly half if this is 90 up here, right? Then going counterclockwise, which is going up, is going to be positive 45 degrees. If I go the other direction, which is clockwise, and I want to draw negative 45 degrees, it's going to be exactly halfway. Okay, so this is negative 90. And then we're going to use our arrow to show that we're going downwards. So this will be negative 45 degrees. I'm going to use the two interchangeably. Okay, so I'll ask you to sketch positive and negative angles. Now, before we move forward, it's important to know a few things about this coordinate plane. The positive x-axis, the ray pointing to the right, we've talked about, is always the initial side. And we need to know that it starts at 0 degrees. Okay, so this line right here is 0. As you move through each quadrant, so if I start here and I move up one, down, right, going around and around, if we start at 0 here and then I move this way, we know that this is 90 degrees. If I have two 90-degree angles, that's 90 plus 90, which is 180. 180 plus another 90 is the same as 90 times 3, right? So that's 270. And then we're going to go back, and this can be 360. Okay, and I could keep going over and over, and it's really just multiples of 9. Right, so this is 9 times 1, 9 times 2, 3, 4, 9 times 5 will be here again, 9 times 6, 9 times 7. So you need to know your multiples of 9, and you need to add a 0. right angles are always 90 degrees. Okay. If we're going in negative angles and we start at 0 degrees, then we're going downwards. Think down for negative, up for positive. Then this is negative 90 degrees, right? So notice it's in a different position. 180 is still the same, but then we go to negative 270 and then negative 360. And the pattern just continues on and on. I can go forever. Okay. So let's do some practice. We will sketch some angles given the measure in standard position. I was going to have you draw your own axes, but I put it in for you. So 140. Please always highlight your initial starting side. It is positive, so we're going to go up. Okay. Now here's where it's sort of helpful to have like a calculator out. You don't need anything fancy, but let me grab my graphing calculator just because I like using that for ease of seeing what I'm typing. So I know that 140 is going to be past 90 and not quite to 180, right? So then the question is, how far do I go? Well, I know that this is 90, this is 180. You don't have to label that part, but what's between 90 and 180? So 90 plus 45, right? Because halfways are 45. So it's a little bit more than halfway. So let's imagine, here's my halfway mark, and I'm going to go to here. Okay? Now, is it super important, and am I going to check you extra carefully if you don't do it perfectly and you're exactly at halfway, let's say? No, but you need to be able to like figure out or understand, how did I know that it was past halfway, right? So then we have to label 140 degrees on here. Make sure you have the arrow to show the direction. Okay? So let's do 300. 300 is past 270. It's 30 degrees past. And I know that this whole thing is 90, right? So it's 1/3 of the way past. Does that make sense? So it's 270, so that's 300, and then there's 60 more degrees. I almost forgot my initial value. So this one I want you to be careful of. We're not going to draw the acute angle, right? So we're going to go going positive because it's up for positive. Go all the way past 270 and label this as 300 degrees. Now, how do we do 500? Well, 500 is more than our standard one circle is 360. So the question is, how much more? So I'm going to go 500 minus 360. It's going to be 140 degrees past 360. So here's what we do. We're going to go all the way around to 360. Notice I didn't make a full circle because I have to then keep going. And we knew it was like right a little bit past halfway, same as A. And so this one we label 500 degrees. So now notice it's just a spiral, and it shows me that I went a full circle and then I continued a little bit more for 500. So let's see if you can try negative 800 yourself, right? So please draw your initial side in first. Think about where that is. Hopefully you drew it to the right. Negative. This time we're going negative, so we're going down for negative, right? So the question is, how many circles is 800? Now, you could do it a few ways. You could do 800 and subtract your way, right? And then subtract 360 again and again and again. But some of our numbers are going to get a little crazy. So here's what I'm going to do. 800 divided by 360. So I know it's going to subtract by 2 circles. So 800 minus 2 times 360. See how I did that? 80. Okay, so let me write out here on the side, what did I do? 800 divided by 360 equals like 2.22. I don't really care about the decimal. So then I did 800 minus 2 times 360 to get whatever's left over. Okay, and that was 80. So that means I'm going to go negative around 2 times. Here's 1. Here's 2. And then I'm going to go 80, which is almost to 90 degrees. Make sure I have my arrow for direction, and that's negative 800. Okay, nothing too crazy. So the next two topics are called coterminal angles and reference angles. In example 1, if you take a look at these 4 problems, 1a, oops, I switched those numbers, sorry, 1a and let's say 1c and 1a are 500 and 140, but they both end at the same place. Remember we talked about that briefly? These are called coterminal. Because their terminal sides coincide, which is just a fancy word for are at the same place. Okay, they end at the same place. Coterminal angles can be found by adding or subtracting multiples of 360 degrees. Okay, it's the same as like adding 360 and 360 and 360. So if I take 140 plus 360, I got 500, but it looks the same if I ignore the spirals. I could add another 360 and get the same angle, right? So now what we're going to do is we're going to find 2 positive and 2 negative coterminal angles for each of the following. So I want you to imagine, we don't need to sketch this, but 80 is going to be, we could sketch it I guess, right? It'll be somewhere here. And then if I want, here's my coterminal positive. If I'm going to get a full circle more, I'm just going to do 80 plus 360. And that'll be 440. That's 1 positive. And I'm going to add 360 again. That'll be 800. Okay? So from here to here was plus 360 degrees, and then I added again to get to that one. Okay? Now how do I get negative coterminal angles? Well, it just means we're going to go backwards, right? So from 80, if I subtract 360, what do I get? So let's show your work here. We'll do plus first, just so you can see that, sorry. And then plus 360 again equals 800. And so we're going to do the same thing and go 80 minus 360. Which is negative 280. And then minus 360 again, which is negative 640. Okay, so I have negative 280 and negative 640. And if you sketched these 4 angles, they would be in the same place as 80. Okay, I don't think I really need to do more with you. At this point, you're adding 360 2 times, right? So for this one, you add 360 2 times. And then for negatives, you subtract 360 2 times. Okay, go ahead, go for it, fill those in yourself, practice them. I'm going to pause the video and then I'll show answers real quick. Okay, so take a moment, check your answers so far, and I do want to do a quick check on this last one because there are multiple options that you can do, and I actually prefer to get the 2 positive angles, the 3 positive angles that are closest to 0. So if you take a look and you try negatives, okay, and you subtract 360, subtracting 360 from 395 does not give you a negative number. It gives you 35. So 35 degrees is actually one of my positive coterminal angles. From there, if I add 360 and add 360, that one I can't use because it's, it's 395. But 395 plus 360 is 755. Okay, I wouldn't have taken off points if you went and gave me 1115. That's also okay. Okay. However, if you put positive 35 for a negative coterminal angle, that would not be okay. So let's go to 35, because that's our smallest positive number, and subtract 360. Okay, so that's my first negative coterminal angle. That's my second one. Okay. The last thing we're going to talk about today is reference angles. And reference angles, let's write this down. The reference angle is something that will help us simplify these really large numbers. So if of the angle, a reference angle is the positive, it's always positive, and it's acute. You guys remember what acute is? It's an angle between 0 degrees and 90 degrees. Angle between the x-axis and the terminal side. Oops, I don't need to write side again. Okay. The easiest way to identify the reference angle. Now, make sure you know that the final answer that you get for reference angle is always going to be positive, and it's always going to be between 0 and 90. Okay? The easiest way to identify the reference angle is to draw a straight line up or down from the x-axis to the terminal side. And I'm going to write in here, ignoring multiples of 360. So the extra spirals don't count. Okay. So let me show you what I mean. So let's first sketch each of the following angles, and then we're going to sketch and find the reference angle of the following. And for reference angle, we use this angle, theta, sorry, with a little apostrophe. So I don't have to write reference angle every single time. Okay. So let's see. 133 is going to be in the second quadrant. So I'm going to be here. I'm going to use blue for this one, just so you guys can see it. Okay, I'm going to go past 90. We talked about halfway being 135, so I'm going to be right around halfway. Okay, so I'm going to label this 133 degrees. Now, the reference angle can't be 133, because we said that the reference angle has to be between 0 and 90. So, I want you to take a moment, and we're not going to start on the initial side all the time. Sometimes it'll be here, some on the positive side, sometimes it'll be on the negative side. So you're going to start from the x-axis. Okay, so I'm going to put my line here, and I have to be on the left side because the terminal side is on the left. And I'm going to just take a moment and draw this angle straight up. Okay, this right here, that angle that correlates to the line that I drew, that's my reference angle. But what is that angle? Now, some teachers will teach you a different formula for every single quadrant, and I don't believe in formulas like that, because if I teach you one formula, it's hard enough to remember it, let alone giving you 4 to mix up in your head. So here's how I teach it. I know the whole half circle is 180 degrees. Okay. And I know that I am missing a piece, but I know the other side is 133. So I'm going to subtract 133. So if I take 47 plus 133, let's just check. Okay, I always want to make sure my logic makes sense. That means my reference angle, is equal to 47 degrees. And I figured out that by figuring out from 133, how much more do I need to get to 180? And that's a subtraction problem. So let's do the next one. I'm going to sketch first, because that's the deal. We have to sketch negative 254. Negative 254 is between 180 and 270. Let's use a... Okay, so this time, because it's negative, I'm going to go down It's going to be somewhere over here. Okay, negative 254. And notice it's in the same quadrant, so I'm actually going to just draw this. And here, this part, this piece right here only, that's my reference angle. Okay. Now, this is a little bit trickier. I know I'm going past 180 to 254. So my question is like, what plus 180 equals to 254? Well, this shows me that I'm going to subtract 180 to both sides. Notice here I needed to know what plus 133 equals to 180, right? So in each scenario, we're subtracting something different because we know that we went all the way to 254, so that's my total, but I only know 180 of it. So what's the remaining piece? So 254 minus 180 is 74. So my reference angle is 74 degrees. Okay, I'll show you a different one because every single one of these is like just slightly different, so it's a little confusing. So you do have to set up this geometry logic here, okay? So positive means I go up. 317 is like almost to 360. Would you agree? So I'm going to be somewhere in this area. Okay, so I'm going to go positive 317, label it. And reference angles are drawn from the x-axis to the terminal side. So it's going to be on the right side here. Here's my reference angle right here in red. Okay. So notice there's a few different ways you can do this. We know two different things. We know either 180 or we know the whole thing is 360. So there's two different equations you could set up. You could say, well actually you need what's left, right? So 180 is not helpful because if we take 180 plus something, we don't want this piece. We need the missing piece. And when we need the missing, like what's left, that means I'm going to take 317 plus what equals to 360. Okay. Now, it wouldn't be helpful to take 317 minus 180 because if I minus 180 and I'm left with this piece right here, that doesn't help us, right? Because we want the piece over here. So now we can do 360 minus 317. That is reference angle of 43 degrees. Last one, 45. Saved the hardest one for the end, of course. Watch this. It's going to be halfway. We're going up, right? So it's 45 degrees here. And guys, if I'm going from the x-axis up to the terminal side, like that, this is my reference angle. So my reference angle is 45 degrees. Okay. Oh, just right here. Okay, so I think what's going to be the hardest is these other three quadrants. It'll take a little bit more figuring out, and we'll keep practicing those. Try your homework tonight, check your answers on there, and we will make sure that we go over and review things that you might need to review.